Innovation is the practical implementation of ideas that result in the introduction of new goods, services, and improvement in offering goods. Innovation often takes place through the development of more effective products, processes, services, technologies, hard work, or business models that innovators make available to markets, governments, and societies. Innovations surround us every day. A key for their emergence is an idea-rich environment which, at the same time, is capable of interconnection, recombination, and massive sharing of all the thoughts and ideas. Some of these innovations are even a result of trial and error. Nowadays, their growth is closely related to the size of social networks and to the easy transmission of information. However, the concept of innovation can be understood is in a much broader context. It does not necessarily have to be connected with today's technology and trends. Even some decades ago, every invention was perceived as innovation at the beginning, even though some of them might seem to be outdated now.
How do you do it? Innovation is all about coming up with new ideas or improving old ones. We can think about innovation as a process to create these ideas and test them. From scientists to designers, artists to engineers, anyone can innovate to solve problems. This process starts off with a need or a challenge. What is a problem that you might like to solve? Have a think about all the different ways to solve this problem. What already exists? What materials can you use? Think about some inspiration from the world around you, or even ask some friends to help you come up with some ideas. Then make a prototype. A prototype is like a draft. It doesn't have to be perfect, or work properly, or even use the same materials as the final product. Often, you'll make lots and lots of prototypes before your final design. In order to figure out whether it does what you want it to do, you need to test it. This is often the part where you learn the most about your idea. Is your prototype doing what you want it to do? Can you improve it? What changes would you like to make? After testing your prototype, figure out what you want to change and refine it. Did it fail completely? Great! Use this failure as feedback to help improve it. You can change something big or small, or even go back to the drawing board and start from the beginning. Innovation is nothing new. Everyone has done it at some point in their lives, whether it's making a new invention, coming up with a new dance routine, or even writing a story. Have a look around you. Are there any problems or challenges that you'd like to solve? Next time you have a problem, have a go using this process. Have a go thinking, making, trying, and refining. You never know what you could come up with.
Innovation and business are two different concepts having entirely different meanings. However, there is a striking relationship between innovation and business which sometimes causes confusion. The main difference between innovation and business is that innovation involves introducing something new. This can be a new business model, product, idea, or service. On the hand, business involves turning a great idea into a business opportunity. Therefore, business begins with innovation. Moreover, there is a risk component in business that is not there in innovation. Let us consider each term separately to determine the differences between them. In 1752, Benjamin Franklin started experiments with electricity. While trying to prove lightning was electricity, he flew a kite in a lightning storm with a key at the end, and the lightning touched the key which made a spark. Many people think Benjamin Franklin discovered electricity with his famous kite flying experiments in 1752. Franklin is famous for tying a key to a kite string during a thunderstorm, proving that static electricity and lightning were indeed the same thing. However, that isn't the whole story of electricity. Electricity was not discovered all at once. At first, electricity was associated with light. People want a cheap and safe way to light their homes, and scientists thought electricity might be a way.
Come, let's see how electricity works.
Hey guys, Paul here from theengineeringmindset.com. In this video, we are going to be looking at how electricity works. Now this is pretty essential knowledge for any engineer, so we'll run through the basic parts of what you need to know. So let's start at the very basics, and for that we need to take a look at the atom. Everything, including you, is made from atoms. All the materials we use are made from atoms. The materials are just different because the construction of their atoms are slightly different. The atoms are made from 3 particles, 2 of which are found inside the nucleus, and the third particle sits outside this. At the center of the atom we have the nucleus. Inside the nucleus we have the neutrons, which have no charge, and we also have the protons, which are positively charged. The neutrons and the protons are much heavier than the electrons, so these will stay within the nucleus. Surrounding the nucleus are different layers of orbital shells. These are like flight paths for the electrons. The electrons flow along these flight paths much like a satellite orbits our planet, except that the electrons travel at almost the speed of light. The electrons are negatively charged and they are attracted to the positive charge of the protons. The electrons orbit around the nucleus in these orbital shells, and there are a set number of how many electrons can be in any one orbital shell. The number of protons, neutrons and electron an atom has tells us which material it is. Atoms hold on to their electrons very tightly, but some materials will hold on to them more tightly than others. The outermost shell is known as the valence shell, and in this shell some materials have loosely bound electrons which can flow to other atoms. Atoms which can pass electrons are called conductors, and most metals are conductors. On the other hand, atoms which do not have free electrons and so they can't pass electrons between other atoms are known as insulators, and these are things like glass and rubber. Now we can combine these materials to safely use electricity by having the conductor in the center, which allows electrons to move, but surround this with an insulator to restrict where they can flow to, i.e. not into us, which keeps us safe. If we look inside a slice of copper cable at the free electrons surrounding the nucleus of the copper atom, you'll see that the free electrons are able to move to other atoms, but this happens randomly in any direction. If we then connect the slice of copper cable to a closed circuit with a power source, such as a battery, then the voltage will force the electrons to move, and these will then all flow in the same direction to try and get back to the other terminal of the battery. When I say circuit, this just means the route which electrons can flow along between the 2 terminals, the positive and the negative, of a power source. So we can add things into their path like light bulbs, and this means that the electrons will have to pass through this in order to get to the other terminal, and so we can use this to create things such as light. The circuit can even be open or closed. In a closed circuit, that means the electrons can flow around, and in an open circuit, this means that the electrons are not able to flow. Voltage is a pushing force of electrons within a circuit. It's like pressure in a water pipe. The more pressure you have, the more water can flow. The more voltage you have, the more electrons can flow. But what does a volt mean? Well, a volt is a joule per coulomb, and a joule is a measurement of energy or work, and a coulomb is a group of flowing electrons. We'll have a look at what a coulomb is in just a second though. So a 9-volt battery can provide 9 joules of energy in the form of work or heat per group of electrons that flow from one side of the battery to the other. In this case, the current of electrons flow from one side of the battery through the LED light bulb, which produces light, and then the electrons flow to the other side of the battery. Therefore, 9 joules of light and heat is produced by the light bulb. Current is the flow of electrons. When a circuit is closed, it means electrons can flow, and when the circuit is open, no electrons will flow. We can measure the flow of electrons just like you can measure the flow of water through a pipe. To measure the flow of electrons, we use the unit of amp. 1 amp means 1 coulomb per second, and 1 coulomb is a group of electrons. The group is incredibly large and is approximately 6,242,000,000,000,000,000 electrons, and that has to pass in 1 second for it to equal 1 amp. That's why electrons are grouped together and just called amps to make it easier for engineers. Resistance is a restriction to the flow of electrons in a circuit. The wire which carries the electrons will naturally have some resistance. The longer the wire, the greater the resistance. The thicker the wire, the lower the resistance. The resistance to the flow of electrons is different for each material, and the temperature of the material can also change the resistance to the flow of electrons. Electrical circuits use specially designed components known as resistors to purposely restrict the flow of electrons. This is either to protect other components from too many electrons flowing through it, or it can also be used to create light and heat, such as in an incandescent light bulb. Resistance occurs when electrons collide with atoms. The amount of collisions is different from one material to another. Copper has a very low collision rate, but other materials such as iron will have much more collisions. When collisions occur, the atoms generate heat, and at a certain temperature the material will then start to produce light as well as heat, which is how the incandescent lamps work. When a wire is wrapped in a coil, it will generate a magnetic field as the current passes through it. The cable will naturally create an electromagnetic field by itself, it's just intensified by the coil. By wrapping it in a coil, the magnetic field becomes so strong that the magnetic field starts to actually affect the electrons within the wire. But we'll look at why this occurs in a future, more advanced video. We can increase the strength of the magnetic field simply by wrapping the coils around an iron core. We can also increase the number of turns within the coils, and also we can increase the amount of current passing through the circuit. Now this is how electromagnets work, and it's also the basis of how induction motors work. If you want to learn more about induction motors, we've already covered this in another video already, just see the link on screen now. Now when a magnetic field passes across a coil of wire, it will induce a voltage in that wire caused by an induced electromotive force which is pushing the electrons in a certain direction. If the wire is connected in a circuit, then this electromotive force will cause a current to flow. This is the basis of how AC generators work, and the electricity at your wall sockets within your home is produced in a very similar way. Transformer. Now we can combine all of the aspects together that we've just covered, and when we do so we'll see that we can use one coil to generate electricity, and then we can place two other coils in very close proximity to each other but not touching, and this will create a transformer. The transformer will induce a voltage from the first or the primary coil over into the secondary coil, and this will force electrons to flow if the coil in the secondary side has a closed circuit. Now what's important about the transformer is that we can increase or decrease the voltage between the primary and the secondary coils simply by changing the amount of coils on either side. Again, this is a subject all by itself, so we'll cover this in a more advanced video later on. Now something else which I just want to briefly mention is the capacitor. So a capacitor forces positive and negative charges to separate across two plates when it is connected to a power supply. This causes a build-up or store of electrons within an electric field. When the power supply is cut or interrupted, these charges will then be released, flow up and meet again. This provides a power source, but only for a few seconds until the charges have paired back up again. It's slightly similar to a battery, but capacitors are very common and they're in almost every single circuit board. We'll cover this obviously in more detail in a future video, just be aware of these. So the last part I want to cover in this video is that there are two types of current electricity, that being alternating current or AC and then direct current or DC. Alternating current simply means that the current flows backwards and forwards in a circuit as the terminals are constantly reversed. This is a bit like the tide of the sea. It goes in and out, in and out, in and out, so that it's reversing constantly. Now alternating current is the most common source of power, and the plug sockets in your homes and your buildings and schools and workplace, etc. These will all be providing alternating current, AC. Now on the other hand, we've got direct current or DC, and that simply means that the current flows directly in only one direction. It does not alternate. This is what's provided from batteries, and almost all your handheld devices are from this as well. So we can convert AC to DC and vice versa using power electronics, and this is how we charge and power small devices, and it's also how solar panels can be used to power our homes, because solar panels produce DC power and our homes need AC power, so we have to convert this for it to be usable. So both AC and DC have pros and cons to it, but for sure we'll look at this in another later video. It's a bit more advanced, and there's also quite an interesting history behind why we use AC and DC and the inventors behind that. If you've got 10 minutes, I definitely recommend having a Google or a YouTube of this too. Alright, that's it for this video. Thank you very much for watching. I hope you enjoyed this and it helped you. If you have any questions, please leave me in the comment section below. Also, don't forget to subscribe and check out our website, theengineeringmindset.com.
Four things it boosts the business sector by electricity. Firstly, a lack of consistent access to reliable power cost businesses and the economy as a whole. For example, even with the access to energy, unreliable power makes operating a business even more challenging than usual. Second one, access to power expand the number of varieties of business and job opportunities available. For example, electricity means that businesses such as hair salons, laundromats and welders, all of which rely on energy, can function. Thirdly, power allows business owners and employees to increase working hours. For example, this not only means that they can open their shop earlier and stay open later, but that business owners can complete other worker-related owning and operating a business before and after daylight hours. Lastly, electricity provides business owners with access to online information and resources. For example, power provides business owners with information that is critical to operating their business successfully, whether that information is about local or national market.
Utilities are the backbone of power delivery. They generate, transmit, and distribute the electricity that lights up homes and powers businesses and play a crucial role in building modern economies and reversing climate impacts. As decarbonization has become a global priority, more countries switch to lower carbon energy to achieve more sustainable development. The World Bank estimates that weak utilities and associated power losses take away up to 4% of GDP in some countries. As countries are beginning to recover from COVID-19, their utilities need to be drivers of economic growth and poverty reduction. As countries are beginning to recover from COVID-19, their utilities need to be drivers of economic growth and poverty reduction. Through its global network of experts, businesses will help electric utilities better navigate the technological change and business innovations that are transforming the power sector landscape and underpin the energy transition.
Nearly all parts of the electricity system can affect the environment, and the size of these impacts will depend on how and where the electricity is generated and delivered. In general, the environmental impacts can include: firstly, emissions of greenhouse gases and other air pollutants, especially when a fuel is burned. Second one, use of water resources to produce steam, provide cooling and serve other functions. Thirdly, discharges of pollution into water bodies, including thermal pollution, water that is hotter than the original temperature of the water body. Fourth one, generation of solid waste, which may include hazardous waste. Next, land used for fuel production, power generation and transmission and distribution lines. Then, effect on the plants, animals and ecosystems that result from the air, water, waste and the land impacts above. Last one, some of these environmental effects can also potentially affect human health, particularly if they result in people being exposed to air pollutants in air, water or soil.
Environmental impacts of generating electricity. Condenser turns steam back into cool water. Cooling towers are our most obvious feature of these facilities. Large steam clouds come off them. Environmental pollutants. Power plants fueled by coal and natural gas. Fossil fuels emit atmospheric greenhouse gases, compounds that lead to ozone, acid rain, heavy metals. Nuclear power creates hazardous radioactive waste. Electric power lines and substations take up space, impede scenic views. Trees must be trimmed and disturbed. Some worry about living near high-voltage power lines. Magnetic field from wires.
10 advantages of electricity. Firstly, it is a clean, safe, cheap and convenient source of energy. Secondly, lower maintenance costs, that is, more efficient. Fourth, no tailpipe emissions. 5. We all know that it can be set up in many sizes. 6. It doesn't require as many employees. 7. Reduces greenhouse emissions. 8. Relatively low maintenance cost. 9. Hydroelectricity produces no gas emissions or waste. Lastly, a station can operate and run for a long periods of time. The 10 disadvantages of electricity. First, more expensive than gasoline. Second, loss of fish species sometimes messes up wildlife. Thirdly, dependent on precipitation. Fourth, more power plants and more pollution. Fifth, damming can cause loss of land suitable for agriculture as well as recreation. Sixth one, cost for construction, change in river or stream quality. Seventh one, an electric vehicle is not completely emission free. 8. In electricity, there are a limited number of visible sites for a large number of dams. Ninth one, drought can affect power production. Last one, hydroelectric nature, seasonal changes in river and ecosystems can be destroyed. Static electricity is an imbalance of electric charges within or on the surface of a material or between materials. The charge remains until it is able to move away by means of an electric current or electric discharge. Static electricity is named in contrast with current electricity, where the electric charge flows through an electric conductor or space and transmits energy. The effects of static electricity are familiar to most people because people can feel, hear, and even the spark as the excess charge is neutralized when brought close to a large electrical conductor, for example, a path to ground, or a region with an excess charge of the opposite polarity, positive or negative, and the familiar phenomenon of a static shock, more specifically an electrostatic discharge, is caused by the neutralization of a charge. The relationship between electricity and productivity is so important that it should be considered in developing federal and state energy and economic policies. To foster increased productivity, policy should emulate increased efficiency of electricity use, promote the implementation of electro-technologies when they are economically justified, and seek to lower the real cost of electricity supply by removing any regulatory and developing promising technologies to provide electricity. Further research should be undertaken to identify and qualify the forces affecting the relationship between electricity and the economic growth in view of their critical importance, complexity, and regional diversity. The discovery of electricity was a turning point of history because without it, we will not live in this world that we live in today, which is filled with life-changing technology, but it all needs and uses electricity. Without electricity, you will not be able to view this page or on your computer at this very moment. Electricity is something that we live in by, whether we notice it or not. Some of us will not be able to survive without it because it is a must-needed source to our everyday lives. It is used to help save people in education, hospitals, and many more. We live by these incredible rations that Mother Nature has given us, and we have been able to control it with our every own hands throughout centuries, especially in these crazy changing worlds where things are being invented and created every day. It will not be possible without electricity.
The Innovation in Businesses World in 2050.